Hi, it's September 14th, 2020. Our target today. We recognize that the sun provides the energy that drives convection within the atmosphere and oceans, producing winds. We can identify how global patterns of atmospheric movement influence local weather using weather maps that show high and low pressure and fronts. And we can identify the role of oceans in the formation of weather systems, such as hurricanes. Don't forget to click that daily attendance link in Schoology, view the lesson video, which you're looking at now, and do your notebook reflection on page 16 and 17. You also have a vocabulary quiz based on those words that you did with the lesson on Friday. The vocabulary quiz is due today, but it will not lock out today, so you'll have some time. So if you get behind today, you can let that go and maybe pick it up tomorrow with no penalty. If you got behind on the notes, make sure you know the vocabulary words before you do it. For today's reflection, you will be using page 16 and 17 in your notebook. So you have two different reflections, but it's the same activity on both sides. On one side, you're going to research any catastrophic hurricane within the last 50 years. Write a strong paragraph detailing the strength and impact of the storm. Make sure you include the date and location of the storm. On page 17, you're going to do the same thing, except you're going to do that for a tornado. So you're going to research any catastrophic tornado within the last 50 years. Strong 8th grade paragraph. Detail the strength and the impact of the storm and include the date and location of that tornado. So when is this due? Well, you should be working on it today. It will not, I won't see it until you turn in notebooks for the second notebook check, which is going to be on this Friday. Second notebook check this Friday. So let's get started. We're going to start off today looking at why high pressure systems are associated with nice weather. So if you remember on page 15, I had asked you to stop at number 7 because we hadn't done that yet. So we're going to get that done today. So here we go.
With me every night here. So every night on Fox 9 at this time,
yes,
we like to turn to Scott and gives a little closer look. Yeah, he teaches us something usually. Actually, for that matter, Scott, a lot of times it's a weather whiz kid who teaches the older folks here something. Older.
So what are we going to learn tonight, Scott?
What are we going to learn tonight? Well, some of the basics to weather. What makes nice weather? What makes stormy weather? That's simple, right? Here's the question from Eagle Middle School.
Hi, my name is Jody Gilbertson, and I go to Eagle Middle School. And my weather question is, why is it that high weather pressure is associated with fair winds and clear skies, but low pressure is associated with dark clouds and precipitation?
Great question. So we're talking high pressure and low pressure. She's saying, why is high pressure associated with clear skies and light winds, and low pressure associated with storms and rain? Well, we're going to put it together this way. You have to look at weather as three-dimensional. That's the key here. That was one of the most difficult things when I went to college. When they started talking about the weather in 3 dimensions, I was so used to just staring at weather maps that I'd see in the newspaper here down at the ground. But everything at the ground is occurring by what's happening aloft here. So let's look at the jet stream. This is the jet stream here. And this is high and low pressure here. Now, you have to understand the water cycle, too. Water cycle is as air rises, it will cool and then condense because it encounters lower pressure. So the higher air rises, the pressure goes from high pressure to low pressure. You get less pressure, less temperature. It cools, condenses, makes clouds. So wherever there's rising air, we get precipitation. This is what's happening in the jet stream aloft. Here we'll have a convergence zone aloft here. That's when the jet stream winds are coming together. So as you push the air together, it has nowhere else to go. It can't go up, so it has to go down. And so what happens is we have sinking air, and the air sinks, and it sinks clockwise. So it subsides, as we call it, subsidence. As it's sinking, it warms because it encounters the higher pressure near the ground, and that sinking air also causes a big bubble of high pressure to form here. So sinking air near the high pressure warms and dries, and so you don't have any cloud cover out. We had that pretty much during the day today. As the jet stream is going along, it'll encounter an area where it diverges aloft, and so it separates the air here. We can't have a void. We can't make a vacuum of no air, so something has to replace the air right here, and so air comes up from the ground. So what happens is high pressure now has been over here, so that wind comes out of high pressure. It goes into low pressure counterclockwise. It gets to the middle with nowhere else to go, and it rises to fill this void right here. And so near low pressure, we have rising air. And rising air will then cool and condense and make clouds and precipitation. So you basically have rising air causing clouds and rain, while sinking air is generally dry as it warms up. And if you look at high pressure, low pressure on the ground at the surface here, you also have wind that forms between the two. And as I mentioned to the kids, if I take a room and we fill it up with air, we seal it off, and we pump a bunch of air pressure inside the room, then we open the door, the air will rush from high pressure to low pressure outside the door, and because the earth is spinning, it goes around clockwise like this. And so we added a little bit extra here, but generally stormy, not stormy. That's what you got to take away from that, Don.
We don't get quizzed on this, do we?
Oh, yeah. Sitting on your desk.
End of the week, my friends. Let's keep him on his toes.
Okay.
Thanks, Scott.
You bet.
Samsung shook up.
So to reiterate what he said, nice weather is associated with high pressure systems because as air leaves the high pressure area, the remaining air sinks slowly downward to take its place. That's going to make clouds and precipitation very scarce because the clouds depend on that rising air for condensation to make the clouds. So high pressure areas are usually going to be nice, fair, settled weather. Remember, high pressure equals happy weather. So why is poor weather associated with low pressure systems? Same, just flip it. When the pressure's low, the air is free to rise into the atmosphere where it cools and condenses. Low pressure air is warmer, it's lighter, it has less dense. So the condensation forms clouds made of water droplets and ice crystals around dust particles in the sky. Eventually, the water vapor in the clouds condenses and falls as rain. Without low pressure, much of the air and the water vapor within it wouldn't reach a high enough altitude to condense, so it wouldn't rain. This is why when you see areas of low pressure, rain often follows. We remember this by saying that low pressure equals lousy weather. What are the types of tropical cyclones?
What's the difference between a hurricane, a typhoon, and a cyclone? I'm Storm Shield meteorologist Jason Myers, and the short answer to your question, absolutely nothing. It all just depends on where these storms form, and they just have different names in different parts of the world. In the Atlantic Ocean and the Northeast Pacific, basically the waters surrounding the United States, we call them hurricanes. In the Northwest Pacific near Asia, it's a typhoon. In the South Pacific and the Indian Ocean, it's called a cyclone. And if I may edit what I said before, there is a slight difference between some of these storms. The direction they spin. Storms in the northern hemisphere spin counterclockwise, and they spin clockwise in the southern hemisphere. All these storms use the same ingredients to form: a weather disturbance, warm tropical oceans, moisture, and relatively light winds. If the right conditions stick around for long enough, we can end up with a huge storm, one that has winds of 74 miles an hour or greater, huge waves, lots and lots of rain, which eventually leads to flooding. I hope this video was helpful. If so, please like and subscribe to the channel.
Tropical cyclones include hurricanes, typhoons, and cyclones.
Dear Tim and Moby, what are hurricanes and where do they come from? From Josh. Good question, Josh. A hurricane is a type of tropical cyclone, a large swirling storm with strong winds and lots of rain. Tropical cyclones form over the warmest parts of the ocean. They start when warm water heats the air right above it. That makes the air less dense, so it rises. Cooler air rushes in to fill the space left by the rising air molecules, and the process continues. The ocean heats the air, it rises, and more air rushes in. This is what weather reports refer to as a low-pressure system. It's sort of like a big vacuum, sucking up air from all around it. Good question. The cool air wants to travel in a straight line, but the spinning of the Earth curves its path. The high winds kick up the ocean, causing big waves and rough seas. Meanwhile, in the center, warm air continues to rise, adding more and more energy to the system. The warm air carries water vapor with it, which condenses into clouds and rain. As the system grows stronger, the low-pressure center becomes a well-defined eye. Even though the strongest winds happen right around it, it's always calm, sometimes even sunny inside the eye. The storm is now a tropical depression, a massive system of wind rotating around a column of low-pressure air. Well, winds move the storm across the sea, and as long as it's over warm water, it just gets stronger and stronger. Once the winds reach 74 miles per hour, it's officially a Category 1 hurricane. The strongest hurricanes are Category 5, with winds over 157 miles per hour. In other parts of the world, hurricanes are called different things, like typhoons and cyclonic storms, but they're all basically the same thing. Right, I was getting to that. Hurricanes start to run out of steam when they hit colder waters or land. They end in a big old downpour. But before they're through, they can cause serious damage. The wind can rip up trees, destroy crops and houses, and push giant waves called storm surges onto shore. That can lead to heavy flooding, which is never a good thing. Unfortunately, we can't stop these storms from hitting land, but we can be prepared. In the Atlantic, hurricanes form from June through November. During this hurricane season, weather scientists called meteorologists keep a close eye on the ocean for signs of tropical depressions. Using satellite imagery, they monitor the progress of these storms. Once a storm gets strong enough, meteorologists give it a person's name. That makes it easier to communicate with other scientists and the public about this particular storm. Meanwhile, computer simulations predict what the storm's path might be. It's an inexact science, but the predictions help everyone prepare. If you live somewhere that a hurricane might hit, the National Weather Service will issue a hurricane watch for your area 2 days in advance. Once it's known for sure what the storm's path will be, a hurricane warning is issued 36 hours in advance. Watches and warnings give everyone plenty of time to get ready. Well, your family can get together and make a storm plan. Agree on a place to meet if you get separated during the storm, and write down any phone numbers you may need. Put together disaster kits with things like food and water, a battery-operated radio, a flashlight, and any medicines you might need. Be sure your family has a plan for evacuation, in case it comes to that. And don't forget to include your pets in your evacuation plans. Some public shelters don't allow animals, so find out in advance what the rules are. Unless you're ordered to evacuate, it's best to stay inside your home during a hurricane. It may look like an ordinary rainstorm out there, but the winds can quickly gust up and knock down trees, electric lines, and other dangerous stuff. You may have to turn off your home's power, but you can keep up with the news on your radio. The last time we rode out a hurricane, we played board games by lantern light. Oh yeah, storms can leave behind all kinds of dangerous stuff. So make sure your parents say it's okay to go outside afterward. When you do go out, don't mess around with fallen trees and puddles. If there's a downed power line nearby, they could be really dangerous. Sure, I'd love some... Hey, are these pretzels from my disaster kit? Why are you lying? I can see it right there. Weirdo.
Why do hurricanes form over warm waters?
Cyclone, typhoon, hurricane. All of these names are used around the world to describe the most powerful storm known to man. Hurricanes are unpredictable, but scientists have a thorough understanding of how hurricanes form and sustain their power. In the Atlantic Ocean, hurricane season peaks during the late summer months when tropical waters are the warmest. Hurricanes form from a cluster of thunderstorms that suck up the warm, moist air and move it high into Earth's atmosphere. The warm air is then converted into energy that powers the hurricane's circular winds. These winds spin around a low-pressure center called the eye, which can provide a 20 to 30-mile radius of eerie calm. Encircling it is the eye wall, a towering ring of clouds with some of the fastest wind speeds of the hurricane. Surrounding the eye wall are curved bands of clouds, the rain bands, often tens of miles wide, releasing sheets of rain and sometimes tornadoes. When a tropical storm's winds reach at least 74 miles per hour, it becomes a hurricane. The hurricane then receives a category ranking of 1 to 5 on the Saffir-Simpson scale, based on its wind speed and potential damage. But wind speed isn't always the most dangerous component when hurricanes come near land. It's storm surge. Storm surge is caused when winds from an approaching hurricane push water towards the shoreline up to 20 feet above sea level and can extend 100 miles. 90% of all hurricane deaths are the result of storm surge. While hurricanes can cause mass devastation, just like other natural disasters, they serve a higher purpose within the global ecosystem. Hurricanes help regulate our climate by moving heat energy from the equator to the poles, keeping the Earth's temperature stable. Over time, science has helped us to better understand hurricanes and predict their paths, saving lives through early warning systems and helping us build better infrastructure to protect our cities. The more we study these complex storms, the better we can prepare for them and minimize their impact on human lives.
When the surface water is warm, the storm sucks up heat energy from the water, just like a straw sucks up a liquid. This heat energy is the fuel for the storm. And the warmer the water, the more moisture is in the air. And that could mean bigger and stronger hurricanes. So here we have a graphic of how hurricanes form. I'm going to also post this in Schoology so you can kind of look at that, and that'll help you with that question about the life cycle of a hurricane. Tornadoes.
Tornadoes. Big, funnel-shaped clouds that can rip through a community and leave a wake of destruction. They can form in seconds, change direction in a heartbeat, and their devastation can last a lifetime. Exactly how and why tornadoes occur is still a bit of a mystery, but an indication that one is forming is a wall cloud. Fast-moving winds roll air below into a horizontal vortex above opposing surface winds, similar to a spinning tube. Warmed by the sun, buoyant air near the ground begins to lift a section of the horizontal vortex into a vertical position. The vortex extends toward the ground. As it picks up speed, anything in its path can be ripped apart or thrown in the air. Upper-level winds tilt the rotating updraft called a mesocyclone. This allows the storm to keep growing as warm air is sucked into the storm away from the cool downdraft. The vortex spins like a top, sometimes up to 300 miles per hour. And while some tornadoes move slowly, others can travel over the ground at speeds of over 110 miles per hour. The widest tornado ever recorded, the May 2013 El Reno tornado in Oklahoma, was 2.6 miles across. That's wider across than Manhattan. Research has allowed us to identify the essential ingredients needed for twisters to form in the U.S. Warm, moist air, typically from the Gulf of Mexico, cool air, typically from Canada, and dry air, typically from the Rockies. When these air masses collide, they create the perfect conditions for a tornado. Nearly 3/4 of the world's tornadoes occur in the United States, and the peak season is between May and June. A majority touch down in Tornado Alley, a section of the central United States, but tornadoes have been recorded in all 50 states and on every continent except Antarctica. Tornadoes are very dangerous, and you should never underestimate their power. The average time between a tornado warning and a strike is estimated at a mere 13 minutes, giving residents little time to seek shelter. On average, tornadoes kill 60 people every year in the United States. The deadliest tornado in history was not in the United States, but a tornado that ripped through Bangladesh in 1989, killing an estimated 1,300 people. We measure the amount of damage to land and property using the EF scale, which ranks tornadoes on 6 different levels. From 0, a heavy breeze that can uproot crops, to level 5, enough wind to pick up a house. It's the desire to better understand them that sends scientists into the field year after year in search of answers that can hopefully save lives while putting theirs at risk.
And we end today's video with 8 record-breaking weather phenomenon.
Jason Myers, and here are 8 extreme weather records from around the world. Number 1, hottest temperature. Furnace Creek, California in Death Valley reached 134 degrees Fahrenheit on July 10, 1913, and that record has stood the test of time for more than 100 years. Number 2, the coldest temperature. The mercury dropped to 128.5 degrees Fahrenheit below zero in Vostok, Antarctica on July 21, 1983. In the middle of the southern hemisphere's winter, there was no sunshine, clear skies, and calm winds, making for exceptionally cold conditions. Numbers 3, 4, and 5, the most rain in an hour, a day, and a year. A long-lasting moisture-laden storm dropped a foot of rain in a single hour on Holt, Missouri in the United States on June 22, 1947. Tropical cyclone Denise in the southern Indian Ocean dropped more than 71 inches of rain on the island of La Réunion from January 7th to 8th in 1966. And monsoon rains dropped large amounts of rain on Cherrapunji, India every year. But from August 1860 to July 1861, rainfall totals topped out at 1,042 inches. That's more than 86 feet of rain. Number 6, the most annual snowfall. Awamori City, on the highest peak of the Hakata Mountains in Japan, gets an average of 312 inches of snow every year. Number 7, the heaviest hailstone. A hailstorm on April 14, 1986 in Bangladesh killed 92 people and dropped a hailstone that weighed in at 2¼ pounds. Number 8, most lightning-struck place on Earth. Lake Maracaibo in Venezuela recently earned the top spot by receiving an average of 233 lightning flashes per square kilometer per year. Since mountain breezes in the Andes converge with the warm, moist air over the lake and result in about 297 thunderstorms per year. What kind of weather records would you like to hear about? Subscribe to our Storm Shield YouTube channel and let us know.
Tomorrow, we end the weather unit content by looking at how to read weather maps. I hope you enjoy the rest of your day. And remember, if you have any questions, please email me. My Schoology messaging doesn't work, so email me any questions you have. Have a great day.